All right, children, next what we're going to do is we are going to create our own price index. And the way that you do this is you take the cost of a market basket in a given year, divide it by the cost of a market basket in a base year times 100. So first I'll need to explain what a market basket is. A market basket is just an assortment of goods and services that most consumers in an economy are expected to buy in a given year. So in this economy that we're looking at here, these are people that buy a lot of lattes, ice cream, and cookies. So every year we expect consumers, average consumers, to buy 25 lattes, 100 quarts of ice cream, and 50 packages of cookies. So we're going to look at what these exact same amounts of goods and services, same quality, same amount, and look at how much their prices change, how much all these together cost in 2015, and then how much they cost in 2020, so that we can actually measure how much prices changed overall between these 2 years, over that 5-year period. And so what we do, first calculate the cost of the market basket of goods in the table in 2015 and 2020. Show your work. Okay, so the cost of a market basket in 2015. We have 25 cups of coffee and they're $2 each. So that costs 50 bucks, right? 25 times 2 is 50. So the cost of market basket is going to be, oops, that doesn't look right. It's going to be $50 plus we had 100 quarts of ice cream and they cost $1 each. So that's $100. And then we're going to add to that 50 packs of cookies, $1 each. That is $50. And the cost of a market basket for 2015 is going to be $200. So cost of a market basket for 2015 equals $200. Now we need to get 2020, 2020, and we'll see what that is here. All right, so same exact goods and services, same exact amount, except 5 years later now. We had 25 cups of latte or 25 lattes, and they cost $2.50 each. 25 times 2.5 equals $62.50. 62.5 plus, what do we got next? We have 100 quarts of ice cream times 1.25. That costs $1.25 now. It's going to be $125. I need a dollar sign. 125. And then finally, we're going to add to that 50 packages of cookies, and they cost $1.50 each, and that comes out to $75. Dollar sign again. $75. And all together, now I need to add that up. I'm going to use my calculator. What is that? Oh, no, I'm not. That is $262.50. Okay, so prices have definitely increased. Yoink. $262.50. Okay, now we're going to use 2015 as the base year. Let's do it. We're going to use 2015 as the base year, and we're going to calculate the price indices for 2015 and 2020. So remember, you take the cost of a market basket in a given year, divide it by the cost of a market basket in the base year times 100. The same way we were doing nominal divided by real times 100 for the GDP deflator. So if 2015 is the base year, 2015's price index, you don't have to do anything. It's going to be 100. 100, because it is the base year. Yeah, 2020 is going to equal, we'll go figure that out real quick. For 2020, the cost of a market basket in 2020 was $262.50. 50 cents, divided by the cost of a market basket in the base year, which was 200 times 100. And let's see what that equals. I'm going to have to use my phone, my calculator. I know. Let's break that thing out. 262.5 divided by 200 equals times 100. All right, and it comes out to 131.25, so I'm going to call it 131. Our consumer price index is 131 in 2020. So now we can use those numbers. We can use what we've gotten so far. I need more space. Can I give myself more space? Now we can use those numbers that we've got so far and measure inflation. Inflation between those 2 years, all we're going to do again is use our new minus old divided by old times 100, and that comes out to, well, now it's figured out, 131 is our new, it's the newest year, 2020, minus 100, our old, divided by 100, our old, times 100, and that's going to come out to 31% increase in prices. Between those 2 years, prices increased by 31%. So that's your inflation rate, and that's how you can use CPI to measure inflation. All right, next. Now that I showed you how you get the cost of a market basket, now we're just going to go ahead and start filling out a table. And so here, I'm going to show you how you can use this stuff to see how our nominal salary and real salary are affected. So remember, salary is the money that you take home and pay. Okay, so our base year here, we know that it's 2002 because it tells us right here that that's the base year. Good news. That means that it's going to be 100 because the base year always keeps it 100. Yay. And that also means that if our nominal salary is $90,000 in the base year, then our real salary is going to be $90,000 in the base year. Because for the base year, nominal and real are the same thing because our CPI is 100, and that's because 2002 is the prices that we're comparing everything else to, so it's just going to stay the same. All right, the other ones, we got to do some math. Remember, we take our, let me go show you, I can't show you again. We take our cost of a market basket in a given year, divide it by the cost of the market basket in a base year times 100. So for this one, cost of the market basket in 2000 was $125, divided by the cost in the base year, 225, times 100. Oops, I missed. And that equals what? Well, I'm going to need my calculator. 125 divided by 225 equals times 100, and that comes out to 56. So our GDP, our CPI, I'm sorry. Our CPI in the year 2000 is 56. It's 67 in the year 2001. And then in 2003, remember, it's the same thing, 250 divided by 225 times 100, and that equals our CPI. So let me calculate that one real quick. 250 divided by 225 equals times 100, and that's going to come out to 111. So now we have our CPIs. It's 56, 67, 100, and 111. Now we can use that to calculate our real salary. So if we go back over to the notes that I showed you earlier, to get our real wages, you take your wage rate and divide it by the price level. So our wage rate is right here. Nominal salary is our wage rate or real salary. You take your nominal salary, divide it by the price level. CPI 56 is our price level, so it's 60,000 divided by our price level, 56, times 100, and let's see what that comes out to. Oops, I did the wrong number. 60,000 divided by 56 equals times 100. That comes out to $107,000. I'm just going to round up there. That comes out to $107,000. So, based on how much prices changed between the year 2000 and the year 2002, making $60,000 in the year 2000 was the equivalent of making $107,000 in the year 2002. Let's do it again for 2001. So we had our nominal salary, 80,000, divided by our price level, which is 67, times 100, and that equals what? Well, let's go figure it out. 80,000 divided by 67 times 100, and that's going to come out to $119,000. So again, based on the change in prices, making $119,000 in the year 2001 was, I said that wrong. Making $80,000 in the year 2001 was the equivalent of making $119,000 in the year 2002, based on how much prices changed. Okay, and then finally, we've got 180,000. Whoa, we're really stacking paper now. Let's find out though. 180,000 divided by 111 times 100. Oops, that should say 100. And what does that equal? Let's see. Oh, crap. Want that to all fit. I have to deal with it. All right. 180,000. 1, 2, 3. 80,000 divided by 111 equals times 100. And that's like making 162,000 in the base year. All right. So, by what percentage did inflation increase between 2000 and 2001? Again, we're just using our percent change formula, new minus old, divided by old times 100. And this is what we did before. Remember, we did this already with the GDP deflator, but you also are able to do this with your CPI. Oops, I didn't want that. Okay, and so it's going to be new minus old, so it's 67 minus 55 divided by 55 times 100, and that's going to come out to 67 minus 55 equals 12 divided by 55 times 100, and that's going to come out to 22%. So prices increased by 22% between the year 2000 and the year 2001. All right, so if we look here, assume Taylor, hey, that's me, gets a 25% raise in nominal wages from the year 2002 to the year 2003. Based on the inflation rate from 02 to 03, have Taylor's real wages increased or decreased? All right, well, let's take a look. We go from 100 to 111. So first we got to figure out the inflation. Again, new minus old, divided by old, times 100. And that's going to be new 111 minus old 100 divided by old 100 times 100. And that will come out to 11%. So prices increased by 11%. However, my wages have increased by 25%. I'm going to be better off. Let me show you exactly how that works. So my wages increased by 25%. I subtract the 11% inflation that eats into how much money I've made. That's 24, 10, 14. So I'm actually going to have a 14% increase in real wages. I'm making 14% more money this next year in 2003 than I did in 2002. So I'm better off. Yeah. All right, now number 3, finally. Assume that Taylor got a fixed rate loan from a bank in the year 2000 when the expected inflation rate was 15%. Based on the actual change in inflation between 2000 and 2001, who benefits? All right, between 2000 and 2001, we had a 22% increase in prices. That is going to benefit me. Taylor will benefit, and I'll show you why now. Let's say that the nominal interest rate was 25%. When I walked into the bank, they told me I'm paying back 25%. Okay, however, we were expecting an inflation rate of 20%. So what I was really going to pay back was just 5% interest. That was my real interest rate. So after you account for the changes in price, what I'm paying back ends up being 5% of what I really borrowed. The value of the dollar is not worth as much when the prices go up. So I'm only really paying 5% in the real interest rate. Now, what happened between 2000 and 2001? Inflation rose by 22%. And so if you look here, inflation actually ended up being 22%. 25 minus 22 is 3%. So my real interest rate went down. The value of the dollar I'm paying back is not worth as much as the bank thought it was going to be when they wrote my loan. Does that make sense, children? Hopefully it does. We will continue practicing.